Welcome to my third attempt to record a tutorial for using Excel in the second cells assignment for processing the data collected during the osmosis practical work. First time I tried it, I didn't turn the microphone pack on at all. Second time I tried it, I left it on standby, so I will give it another go. Fingers crossed this time. We need some data for processing. I'm going to use a set of data from 2015. This is available on Moodle in the cells section, and it's in Learning Outcome 2, and it is just the sort of spreadsheet collected data from 2015. It's just a good set to use. It brings up a good graph and things. So I'm going to use this one to demonstrate. I'm just pulling it off my memory stick for now, but it is available on Moodle. So this is what it looks like as a sort of raw data set. This is where students have entered their data. So we will have a group of 3 students known as Group A. They put 5 pieces of potato into each of the 7 different water potential solutions, 0 being pure water, minus 3,510 kilopascals being the 1 mole per decimeter cubed sucrose solution, the others being in between. They calculate, well, they record the starting mass, the end mass, the absolute change in mass, and then the percentage change in mass, which is what's recorded on here. So we would expect those at the lower end to gain mass, so these are positive numbers at the left-hand side, and those in the higher water potentials to lose mass, so we've got negative numbers on the right-hand side. So the first thing we need to do is to identify any anomalies, and it's quite difficult to do just from looking at a table of results like this, although odd ones will stand out, like this one down here, the H3 result there, minus 6.3 in water, suggests the potatoes lost mass in water, which is obviously not possible. However, picking up other ones is quite difficult. So what we do to identify anomalies is to select all the data, missing out group titles and the top title there, selecting the water potentials, and then all of the entered data down to the bottom corner there. And then, I should keep moving that, so bear with me. Then we go to Insert. We're going to insert a chart, and we're going to choose just the scatter that gives us points like that. Now, to start with, that's no use whatsoever. But if you come up here and switch the row and column, you get that sort of effect. And then if you remove all these series labels, and then, again, move the chart to a new sheet, what we get is a graph like this. Now, this shows us the data points for each individual water potential, and it makes it a lot easier to identify possible anomalies here. They have to be the ones that really stand out from the rest. They're not just large or small values, within range. So there are things like, for example, this one here is the only positive result in a set of negatives. So that's definitely an anomaly. Along with the next one here, this one is just so way off the rest of them that I would call that an anomaly. Bit borderline, but I'm also going to take that one as an anomaly because it is an odd one. There's not a spread going out there. And then this one is that obvious one where we've got a negative value in pure water. So we've got 4 anomalies which now need to be identified on the spreadsheet of results, so that when we calculate the mean and the standard deviation, we're not going to include those. So we now need to go back and forth between this chart and sheet 1. The first one, we know it's this one because that just stands out a mile. It's always a bit weird that we get the little red circles on here. The next one along is in the third set of data, and it's a very negative value, which I think we'll find is this one. Right, we go back. We've got this one here, Oh, it actually tells you which it is actually. If you hover over it with the pointer, look, it says -4, 540, that's -16.9, that's the one I've just highlighted. The next one in the -820 column is a -36 value that we're looking for, which is there. And then I can see the other one. The only positive one in that column is the 4 up there. All right, so that's transferring it from the graph of all the data points onto the spreadsheet so that we can then jump over those values when we're putting in the formulae for mean and standard deviation. Next thing I need to do is to just remove those little red circles because they're staying on the smartboard rather than being part of Excel, so let's get rid of those. The next thing we're going to do is to put the mean and standard deviation onto here, and so we need mean there, and I will just put SD for the time being. And what we're going to need is a formula. So we'll click in there. I'll move that down the corner for the time being, see if that's easier. For the mean then, if we click in there, we're going to choose a formula. Recently used ones, they're likely to be, or insert function, you can track them down in there. Recently used will be the ones that have been used on that computer, but I'm going to use the average. So we put average in, and if we click on OK, it then gives us a window to select the cells we want the average of. And you just highlight them on the spreadsheet. So I'm going to start at the top there, don't include the water potentials, scroll down selecting, but when you get to the anomaly, stop at the cell above it, let go of the mouse pointer. Then hit Control and hold it down while you select the 2 underneath. So we've now got all the values in that column except for that anomaly. Hit OK, job done. Next one, put the average in again, OK. Similar job, scroll down. This one doesn't have any anomalies in it, so go to there, OK, job done. Next one, following just the same, practice all the way along. There's no easy way of doing it on this one. We can't copy the formula across because the anomalies are all in different places. So this one, select down to the anomaly, let go of the mouse pointer, hit Control, and then pick up with the mouse pointer again the other side of the anomaly, scroll down to the bottom of the column, hit OK, and so we go. So we can see that the water potential is going to be between those two values. Next one's got an anomaly in. Hang on, I always forget to put the formula in first. Average. Now, this is going to get in the way. Select down to the anomaly, let go of the mouse, hit Control, select the rest. Oops. Hit OK. Again, job done. You can see we're getting quite a nice pattern here. Again, hit Average, OK. Let's move that over the other side. I think we're on this one, aren't we? That one. Then hit Control, go the other side. Oops. Okay. Next one, easy because we haven't got any anomalies in this one, so we just scroll down. Do have to be careful not to pick up values that you don't want. It's very easy to pick up the water potential value, and when we're doing standard deviation, you have to be careful not to include the mean in your list. This one, because there's no anomalies in either of the end columns, you can just copy this one across. And to copy a formula, when you've got it, the green box around it like this, you've got that little square in the corner there. If you sort of click on that, you pick it up, drag it across, it copies the formula but changes the cell references. So there are our mean values. Now we've got to do exactly the same thing for standard deviation, but inserting the function, we're inserting stdev, this one, STDEV. Again, we are selecting the cells but missing out the anomalies. So again, stop above, let go of the mouse, select below, hit OK. Next one, stdev, OK. This column doesn't have any anomalies in it, so again, make sure you don't include the mean in there. Okay. Next one, insert standard deviation. Then go to the top of that column, select down to the anomaly, let go at control, pick up the other side, select down. Okay, these look all right. These are quite small standard deviations, so you'll be able to see that, you know, this is what we're going to want in terms of precision. The most precise results, the ones with the smallest standard deviations, are going to be either side of where we estimate our water potential to be. So that gives the students something to comment on, which is quite nice. And then the others will have bigger values, just pure chance. Where have I got to? This one? Can't remember now. We'll see when I get to the bottom. That one. Okay. And again here we've got standard deviation. Okay. And this time it's just that one. Jump over, hit control, pick up the rest of them. Whoops. Avoid the mean. Hit OK. And see the standard deviations are getting bigger. Nearly there. And then we can do something with these in terms of building a graph. Okay. Select the whole column for this one, not the mean. Okay, and then that one we can just pick up there and copy across. So we've now got all the means and the standard deviations for the whole data set except the anomalies. And the mean, of course, is related to accuracy because we've got a large number of data pieces, so it improves the accuracy of the mean. And the standard deviation is about precision, so we can talk about accuracy and precision with those. The next thing we're going to do is to start drawing the graph. And we're going to start by just plotting the basic graph. And our independent variable is just these 7 numbers across the top. So select those, scroll down, hit control, and then select the mean values. We then go insert, and under the charts we choose a smooth curve, scatter with smooth lines and markers. And that makes quite a decent graph in itself, but I'm going to do what I did before, move that to a new sheet because it's so much easier to work with when it's just like that. Okay, nice graph. Now, what can we do to it? All sorts of things. Let's start with some of the basics. We can edit the horizontal axis, for example. We can, no, hang on, I don't know if I want to do that first. No, let's put the error bars on. If you select the line just by clicking on it, you click off and on, well, on and off it, it will select it so you can see the data points get picked up. Right, oh, I've picked an odd data point now, let's try again. Select that line, all right, so all the points come up. If we then go to add chart element, and I'm not sure that all the computers show it in the same place, but you'll find it somewhere, add chart element, error bars, not the standard deviation one, because I don't know what that does. But if you look what it's done to the graph, if I hover over that, it's not what we want. So I just go to more error bar options. It opens up a window at the side here. And what I do on here is to choose custom. Now, if we specify values, it gives us a little window to put our standard deviations in. So in that first positive value, I remove what's there, go back to the sheet, select the row of standard deviations, oops, job done. Same for the negative. So it will draw little lines up and down according to the values of these. So in the negative, we also put the standard deviation values in, across there. We click OK, and there we are. We've got rather nice little standard deviation error bars on there. And you can see that the smallest error bars are either side of the point where the line crosses the axis. While we're on them, let's just select them. If you click on them, you can change the colour of them, for example. I'm going to make them red so they stand out. Okay. And there are other things now to notice. Now, by putting the error bars in, it's taken up a bit more of the vertical axis, and that has caused the x-axis to stretch out to a positive number, plus 500, which means nothing on this. We don't have positive water potentials. So we've got to click on the x-axis like that, and it gives us this box where you can, if you, I think what one we actually, I think I'm going to try clicking on that one. Nope, wasn't that one. Try that one. Axis options, I think, yeah. If you can get to axis options like that somehow, you can change the maximum and minimum values. Now, we just want to change our maximum value there to 0. If we click onto the graph, you'll see that it's taken away that extension that was meaningless. Now, other things that you can do, we can go back to that x-axis. We can do things like changing the weight of it, 'cause at the moment you can't really see it. So I'm going to change the colour of the vertical axis to black, change its weight to 1, and then if you click on the graph, you'll see that that's now much clearer. I'll do the same for the horizontal. Click on it, change it to black, make its width 1, and again, it's now a visible line. Now, the chart title at the top can be edited there. You can also add grid lines, which is quite useful. Primary, minor, and primary, hang on, grid lines. Sorry, primary, minor, vertical, primary, minor, horizontal. Put those in. They're very pale on there. You can change the divisions on those by going back to the axis editing, but I'm not going to do that at the moment. You can put axis titles on, so a horizontal axis title, for some reason comes down here, not terribly useful there. I would rather have it up here, which would be water potential in kilopascals. And similarly, axis titles vertical, but it comes over here, which is fairly unhelpful. I'm going to drag it over here, but then you'll see, oh, I haven't got enough room for it over here. So it pops back over there. You can make space over here. If you click on the edge of the graph like that, you get picture border and these little circles. And all you need to do is to drag that in. Then you can move your axis title over here. And there you are. So we've now got them where we want them. All right, this is looking much better now. You can change the weight of the line, the colour, and all sorts of things if you want to, but you don't really need to be honest. Same with the standard deviation bars. You can make them heavier if you feel that way inclined. The other thing that I would suggest on here, I mean, you know, you can always ask me any bits that don't make sense, is reading the actual value of the water potential off here is quite difficult. But what I would suggest doing is zooming in using this slider down in the bottom right. So you go enlarge it, make it bigger and bigger and bigger and bigger, and moving it about so you actually focus on that bit. It looks like about minus 450. And what I've had students do in the past is to use the snipping tool, which is, and you start menu thing there, the snipping tool, and actually snip out a piece of the graph like that. That's not, I haven't actually selected that very well. And then they can include that in their write-up because they can paste it in like a picture and actually say, you know, the value of the water potential from the graph is seen to be, and put that in. You can treat that like a picture, you can put a board around it, and, you know, I'd cut it a bit better than that perhaps, but it's quite a useful thing to be able to do. Save that, and that. Let's bring that back down to that sort of size. And then obviously this graph with a proper title and axis titles, I mean, can actually just be inserted into the write-up in the results section. The other thing that the results section needs is results from here, but not the whole lot. They don't need all the data, right? It's a huge thing, all that. What they need to do is to create a table out of the top two rows here, which is water potential and those values of an independent variable, and then the group mean and standard deviation from the bottom. So they'll have quite a small results table in their results section. The whole thing can be put in on a whole single page in an appendix. It'll show the identification of the anomalies and give them something to talk about, but we don't want the whole data sheet in their actual main write-up. Hopefully that's reasonably helpful. If there's any particular bits, obviously you can watch this and rewind it, watch it again, and then ask me any questions as necessary. But I will stop at that point and hope that's helpful.